Alright, so we need to use the definition of the derivative, so the limit process. So, uh, oh yeah. So I need f of x plus delta x. So what I'm going to get in here is 4 times x plus delta x minus 5. And now I need to, that's 1, to f of x plus delta x minus f of x, which would be the square root of 4x minus 5 minus the square root of 4x plus 4x. So it'd be 4x plus 4 delta x minus 5 minus the square root of 4x minus 5. And then what do we do? Divide it by delta x. So I need to take this, divide it by delta x. Now, is this really doing anything for us? Alright, so we need to go and figure out one of our kind of cool things to do. Here's the cool thing that I'm going to do. I'm going to rationalize the numerator. And that's 4x minus 5. So I'm going to rationalize the numerator. Remember, when your numerator has a bunch of really crazy square roots in it, we rationalize it because then we get rid of most of them. And so what this does is it's going to give me basically, this is a minus b times a plus b, so it's a squared plus b squared. So I'm going to get 4x plus 4 delta x minus 5 minus 4x plus 5. And then I'm going to have delta x times the quantity of square root of 4x plus 4 delta x minus 5 plus the quantity of 4x minus 5. Alright, is that everything going good okay? Now, simplify this. 4x minus 4x. Alright, so these guys are gone. Negative 5 plus 5. Those guys are gone. And then I can divide out the delta x's in those, and now I'm going to be left with 4 over, let's do this, get rid of that, 4x plus 4 delta x minus 5 plus the square root of 4x minus 5. And now I want to take the limit as delta x goes to what? 0. Now, where's the only delta x? It's right here. So that's a 0. That guy goes away. So this is going to be 4 over 2 times 4x minus 5. The square root of 4x minus 5. Then the 2 you divide that out, you're going to end up with don't rationalize the denominator. Don't do that. And now, let's compare this with, because now this is what my derivative is. F prime of x should be equal to 2 over the square root of 4x minus 5. So, if f of x was equal to the square root of 4x minus 5, is equal to 4x minus 5 to the 1/2 power. F prime of x would be equal to 1/2 times the 4x minus 5 to the negative half power times chain rule for 4x minus 5, which is 4, which is 4 over 2 times the square root of 4x minus 5, which ends up being 2 over the square root of 4x minus 5. Not factorial, but I'm just happy that I did it. It's just the formal definition of it. The whole idea behind it was, when it first started, when calculus first came to be, the limit process was the king. And they didn't have all these fancy rules that we could just, they didn't have a power rule, they didn't have all that other stuff. So at first, everything was based off the limit process. So they used the limit process. As calculus evolved as a study, as a discipline, more rules were found, and we found that the power rule worked. The power rule makes it so much easier to take the derivative of anything raised to a power, any rational power. But this ended up being just some, and when it came right down to it, the trick was, alright, rationalize the numerator, which is, it's good that we saw this again because you're going to need it again. I change it to the or something to the negative 1 power. And that's why it comes up to be a little bit easier. The definition of the derivative doesn't make it easy. I'll be honest, it doesn't.